Alaikum. Today's experiment we are going to show you the setup for two experiments actually, the simple distillation and fractional distillation. But before showing you this or talking about that, let's first define what's the meaning of a distillation. A distillation is a process which includes evaporation of a liquid and then recondensation of that vapors into liquid again. What's the ultimate purpose of such a process? Actually, there are two purposes for the distillation. Either to purify a liquid organic compound or to separate two miscible liquid organic compounds. Now, in the distillation, in the simple distillation, this is the setup for the simple distillation. This will enable us to separate two liquids with at least the difference of the boiling point supposed to be 40 and more, or at least as written in your manual. Actually, the boiling point difference supposed to be higher than 50 degrees in order to be able to separate the two compounds efficiently by simple distillation. So, what are the parts of the simple distillation? As you can see here, we have actually always any distillation, it's composed from the round bottom flask and the round flask with different sizes. We need a heating source, which is in this case the heating mantle. We need to clamp our flask tightly and gently, and then we need to use distillation or distill head here, and this distill head will join two parts. It will join the thermometer, which will be added in the top of the distill head, and as well as it will join also what we call it the condenser. And this condenser, which will be joined to the still head and as well as the receiving adapter. This is how we join it together. We always join it carefully because these are glasses, so we must use a lot of care actually while we try to join it nicely, and then clamp the whole system in order to be able to collect any product you would like to. Now, this is the setup of, I'm just going to use this device here, which will enable us to use different height of the flask of the receiving, or what we call it the receiving flask of the experiment. So what we are supposed to do, actually, we are not going to do the experiment fully, but I'm just going to show you the setup of the simple distillation and the fractional distillation, because these are very important and vital techniques which you need to know. Now, this is simply how we make the whole setup. The most important thing about the setup in here, which I would like to highlight here, that the temperature bulb here, or the thermometer bulb, supposed to be exactly in between the path of the vapors, because that's actually when this liquid heated up, it will be converted into vapors, and the vapors will flow here, and therefore the bulb of the thermometer approximately supposed to be in the half of this opening, in order that our thermometer to measure exactly the temperature of the vapor. So what's going to happen if we have two liquids with a difference of boiling point of 40 and more degrees centigrade? What's going to happen, simply the liquid will evaporate, but of course the liquid which has lower boiling point will evaporate, or it will be the vapors of the liquid of the low boiling point will be more rich of that, what we call it the flammable liquid. So the first fraction, what we are going to get, the liquid with low boiling point, while the remaining liquid, it will be the liquid with high boiling point. That's actually the ideal case when we have two liquids with high boiling point difference. In most of the cases, we would like to separate liquids, but the difference of their boiling point will be very sharp. It will be very little. And for example, as in the second experiment in your manual, which is the separation of ethanol and water. In this case, we will use the same setup exactly like the simple distillation. The only difference in here, as you can see, we will only use this column here. This column, we call it fractionation column. And what's the purpose of this fractionation column is that simply when the vapors here, it's this fractionation column will enable us to do repeated cycles of evaporation, condensation, in order to make the separation of the two liquids more and more effective, according to Raoult's law, which I can't really explain it now on the board, but I hope you have studied this in the General Chemistry 2-102. Now, what's going to happen here? When the two liquids with less boiling point difference than 40 are here in the liquid phase, when we heat them up, they will be evaporated, or there will be evaporation. Now, in general, always the vapors will be more rich with the volume of the liquid which is more volatile. In other words, which has lower boiling point. So when they reach the first phase here, which is the glass in the fractionation column, what's going to happen that this vapor will be simply condensed. It will collide with this glass, with this piece of glass, and therefore it will lose its kinetic energy, and therefore it will condense. Now, with continuous heating, this liquid, which is already more rich with the volatile liquid, will be heated up again, and therefore it will be converted into the vapor phase. The vapor phase always more rich with the volatile liquid, which is in other words with the boiling point or the lower boiling point liquid. So again here what's going to happen, when it evaporates, it will collide with the second piece of the glass in here, which will make it actually condense again. And then again we will continue repeating this, and every time while we do condensation evaporation, the vapors will always become more and more rich unless it reach here, which will be mainly the more volatile liquid, which is in this case the low boiling point liquid, and then it will simply evaporate and then condense, and then we can collect it, and then we can collect the second fraction, third fraction, and so on and so forth. Now, what we use here finally for the condensation of the vapors, we use this condenser. And this condenser here, the most important thing is always we allow the water to pass opposing the direction of the vapors. In this case, as you can see here, in this case, the direction of the vapors going this way. That means the inlet of the water must be opposing the direction of the vapors, so the outlet will be that way. This will also apply to the simple distillation. So that's actually the main important features of the simple and fractional distillation. As I said, I wanted just to show you the setup and how we do it, and the main reason why we use the fractional distillation compared to the simple distillation. So the fractional distillation, it's needed to separate liquids with boiling point difference less than 50, let's say. The simple distillation, we use to separate liquids with boiling point difference higher than 50 degrees centigrade. Something else actually we need to do after we collect the organic product, we need to add some sort of what we call it drying agents, which are salts, which has the ability or capacity to abstract any traces of water which we may have in the organic phase. And then after that, according to your procedure, we need to filter off and get rid of the drying agents. I hope that was a comprehensive, short summary of the whole two experiments, the simple distillation and fractional distillation. Until next week, thank you very much, and Assalamu alaikum.